Hello everyone, welcome back to the session on Laurent series part 3. Myself Dr. N.C.H. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today I am going to express the given function as a Laurent series expansion. So we are going to solve some problems on Laurent series expansion, which we did in the last two sessions also. Now, coming to the first problem, obtain the Laurent series expansion of the given function about z equal to 1. So, here f of z is e power z by z into 1 minus z about z equal to 1. That means in powers of z minus 1. So, about a point z equal to 1 is same as expressing in powers of z minus 1. So, put z minus 1 equal to w. That implies z is w plus 1. Then f of z becomes e power z is w plus 1 by z is w plus 1 into 1 minus z minus w minus 1. So, by simplifying this, e power w into e by this is w plus 1, here minus w into w plus 1. Now, we need to expand this f of z equal to e minus e by w. So, minus e by w into e power w by w plus 1. So, this is minus e by w, e power w into 1 plus w power minus 1. So, minus e by w. What is the expansion of e power w? 1 plus w square by 2 factorial plus w cube by 3 factorial and so on. This is the expansion of exponential function e power w. And here we know this expansion is 1 minus w plus w square minus w cube plus and so on. So, the sign changes alternately since here we have plus and here minus. So, replace w by z minus 1, then this becomes minus e by z minus 1. So, here z minus 1 is w, that is why we are replacing it. 1 plus z minus 1 plus z minus 1 whole square by 2 factorial plus z minus 1 whole cube by 3 factorial and so on, multiplied by the same. We replace w by z minus 1 and so on. Similarly, let us solve one more problem on Laurent series expansion. Coming to the second problem, we need to expand this f of z by z plus 1 into z plus 2 as a Laurent series expansion about z equal to minus 2. So, that implies in powers of z plus 2. So, we try to get the term z plus 2 in the function f of z. By splitting into partial fractions, we get z by z plus 1 minus z by z plus 2. So, the constants will be 1 and minus 1. And now, we try to get the same term z plus 2. So, if I write z plus 2 here, minus 2, that becomes z. Similarly, z plus 2 here, but here we have 1 only. So, therefore, minus 1. Z plus 2 minus 1, which becomes z plus 1 minus z plus 2 minus 2 by z plus 2 itself. Yeah, now here I can take z plus 2 common in the numerator. So, 1 minus 2 by z plus 2 and similarly z plus 2 here 1 minus 1 by z plus 2. So, that is minus here a minus b by c. So, 1 minus 1 plus 2 by z plus 2. So, therefore, this f of z becomes minus 1 plus 2 by z plus 2. So, these two gets cancelled. So, 1 minus 2 by z plus 2, 1 minus 2 by z plus 2 into 1 minus 1 by z plus 2 whole power minus 1. So, minus 1 plus 2 by z plus 2 plus 1 minus 2 by z plus 2, and here we can use the standard expansion. So, 1 by z plus 2 plus 1 by z plus 2 whole square plus 1 by z plus 2 whole cube and so on. So this becomes 1 plus 1 by z plus 2 plus 1 by z plus 2 whole square and so on. Now coming to the last problem of today's session, we need to express f of z in series of positive and negative powers of z. So what is the given? 1 plus 2z by z square plus z cube. Now let us simplify this function. 1 plus 2z by, in denominator we can take z square common. So 1 plus z. So this is now 1 by z square into 1 plus 2z by 1 plus z. Now I try to get the same term in the numerator which we have in the denominator, 1 plus z. So I will write it as 2 plus 2z minus 1. Then 2 minus 1 is 1. So by 1 plus z. So that's equal to 1 by z square into 2 common 1 plus z minus 1 by 1 plus z. So we got the same term in the numerator. So like that we simplify, and now a minus b by c form, it is in a minus b by c form, therefore a by c minus b by c. By writing in that form, we get this expression 2 minus 1 by 1 plus z. Now we need to expand this. So f of z equal to 1 by z square into 2 minus 1 by 1 plus z. So 1 plus z power minus 1. So 1 by z square 2 minus, here 1 plus z power minus 1. 1 minus z plus z square minus z cube plus so on. So this is 2 by z square minus 1 by z square into 1 minus z plus z square minus z cube and so on. So finally the expansion is minus 1 by z square plus 1 by z minus 1 plus z. The next term will be minus z power 4. So z square, next plus z cube minus z power 4 plus and so on. So which is the required Laurent series expansion of the given function. So in the Laurent series problems, from last 3 sessions, we have expanded the given function as a Laurent series in the given region. So today we solved some problems on Laurent series expansion. So this is for today's session, and we will meet in the next session. Thank you.